Hello students, today we'll be discussing about exposed to radiation. It's physics Higher 7.04. We'll discuss about the background radiation, the dangers of radioactive materials, and how we can measure the background radiation and the counter, that means the activity. Okay, so the first point comes like nuclear power stations produce radioactive waste. The containers that carry the waste must be strong enough to withstand crashes like the one above. If any leaked out, it would be a health hazard. Okay, so we know that the countries that have nuclear power station must have to deal with the waste products. That means if they are exposed to the atmosphere, this will cause a very severe effect to the living things. So the containers that carry the waste must be strong enough to withstand the fracture or the breakage. Okay, that means it have to ensure that the containers have to ensure that there is no leakage of the radioactive waste. Okay, now the radiation dangers. Because of its ionizing effect, nuclear radiation can damage or destroy living cells. It can stop vital organs in the body working properly and cause cancer. The stronger the radiation, the greater the risk. That means radiation has some of the dangers. That is, it has ionizing effect. Nuclear radiation can cause damage to living cells, which can cause severe damage to living cells, and it can also cause cancer. So the stronger the radiation, the percentage of the risk or the possibility of risk is greater. Okay, now the workers in the nuclear power station have to wear a film badge like the one above. So this is a film badge. Okay, it reacts to nuclear radiation rather like the film in a camera react to the light. Every month the film is developed to check that its wearer hasn't been exposed too much of the radiation. That means the workers that work in nuclear power station needs to wear a badge, the badge that reacts with the nuclear radiation. That means it will help to protect the workers from the nuclear radiation, and every month they are checked. That means they have to be checked for it has not been exposed too much of the radiation. This must be ensured by the developers of the nuclear power station, of the other members of the group. Okay, now this monitoring device detects radiation from any radioactive radon gas that may have seeped out of the rocks beneath the building. Okay, so this is the measurement. That monitoring device detects the radiation from any radioactive radon gas. That means radon gas is a very radioactive material, and it causes radiation which can be harmful to the living organisms. And now see the dangers from inside the body. Okay, some dangers from inside the body. Radioactive gas and dust are especially dangerous because they can be taken into the body with air, food or drink. Once absorbed, they are difficult to remove, and the radiation can cause damage in cells deep in the body. Alpha radiation is the most harmful because it has the most highly ionizing. Okay, so dangers from inside the body. That means the radiation can enter our body with air, food or drink, and once they are absorbed in the body, they will cause damage to the cells, and which can cause cancer or other severe diseases which can lead to death. And here alpha is the most harmful because it has the most ionizing power. Okay, now dangers from outside the body. Okay, since they have dangers inside the body, there are some dangers outside the body too. Normally there is less risk from the radioactive sources outside the body. Sources in nuclear power stations and laboratories are well shielded and their radiation gets weaker as you move further away from them. Beta and gamma rays are most dangerous because they can penetrate to internal organs, while alpha particles are stopped by the skin. That means we know alpha has the most ionizing power, but alpha has least penetration power compared to beta and gamma. Okay, gamma can never be stopped by any of the material. It has energy like waves. It can penetrate any material, and beta can be stopped, but beta have more ionizing or more penetrating power than alpha. Okay, so wearing a badge is very mandatory if people are working in the radioactive nuclear power station that contains radioactive materials. Okay, now we'll discuss about the background radiation. That is, we are exposed to some amount of radiation all time because radioactive materials in our surroundings. This is called background radiation. It mainly comes from natural sources as soil, rocks, air, building materials, food and drink, and even space. So we are already exposed to some amount of radiation all the time because these are the radiation that come that is known as background radiation. That means these are always emitting, and the sources are like soil, rocks, building materials, food and drink. So we are already exposed to some amount of the radiation. Okay, here is a flow chart. You can see here is a flow chart. Radon gas from the ground and buildings, then food and drink, cosmic rays from the space, then see nuclear test fallout, nuclear power station, nuclear waste and other. Okay, where background radiation comes from, these proportions are averages. The actual proportions vary from one area to another. That means the background radiation varies from one area to another. Okay, in some areas over half of the background radiation comes from radioactive radon gas. Okay, some of the areas they are exposed to too much of the radon gas, and that means it emits more radioactive gas. Okay, that is radon 222 seeping out of rocks, especially some types of granite. Okay, that means rocks like granite causes that radon gas. Okay, in high risk areas, houses may need extra ventilation to stop the gas collecting. Okay, so the areas that contain high amount of these type of rocks needs ventilation for collecting the gas. Sometimes a sealed floor is used to stop the gas entering the first place. That means a sealed floor, this is a method to stop the gas entering in the first place. Okay, and radiation can cause mutation. You can see here, radiation can cause mutation. This is the thing, radiation can cause mutation. That is, living cells contain a complex chemical called DNA. This carries the coded instruction needed to build the body in an animal or plant. The instructions are passed on from generation to generation. That means if your body is exposed to high amount of radiation, that means mutation causes in the DNA. That is, radiation is one of the cause of mutation, that is changes in the DNA. Mutation causes changes in the DNA. Most mutations are harmful, but some are useful. Without mutation, ancient fish with scales would never have been evolved into animals with feathers or fur, and we wouldn't be here. Okay, so mutation is sometimes it is useful and sometimes it is harmful to the living things. Okay, when radiation from the radioactive source is measured, the reading includes any background radiation. Okay, so when you are measuring the radioactive radiation from radioactive source, you must include the background radiation. To find the reading from the source alone, you must measure the background radiation and take the reading away from the total. Okay, so in order to calculate the radiation alone, you must subtract the background radiation. You must first measure the background radiation using tracers or other machine that measures the background radiation, and then you will measure the radiation with the source, and the total count rate must be subtracted the radiation of the radioactive source alone. In order to get the value of the radioactive source alone, you must subtract the total value. You must subtract the background value from the total value. Okay, and the exercise questions, here are some exercise questions, and the answers are given in the description link of the video. If you click on the link, you will get the answers. I hope you are clear with the topic. For any further confusion, if you have any confusion with the video, with the lecture, inform me or comment me on the comment section to let me know about your problems. I hope you are clear with the following lecture. Okay, stay safe. Thank you.